because we've had a few days off, what I'm going to do is I'm going to go over one more concept that I didn't talk about yet, okay, which is rationalizing the denominator when it's not a square root. Okay, and I'll explain that in a minute. And then I'll do maybe a couple sample problems just to kind of get you back in the mood of what we were doing with 7.1. And then I'll just give you a problem, give you a couple minutes to try it, and then I'll do it, and then give you another, and I'll do it, and that kind of thing, just to get our skills back where we left them, hopefully. As I mentioned, WebWork is down. We discovered it over, I think, on Friday. I had a student let me know. I reached out to Travis, Mr. Terrell, and he is trying to figure out what's going on, but the server that it was on, I don't understand IT speak, so I'm going to do my best to explain it. But the server that it was on somehow malfunctioned, and so he's having to rebuild it on a different place, and he's hoping everything will copy over. Okay, so I don't have to recreate all of these assignments, which if I do, I do. But I don't know exactly what's going to be left with what everybody did on 7.1. You already did some of it because it was due. I don't know if I'll be able to see what you did. And so we'll talk about, it may be, I'll take your word that you worked on it and just give everybody 100 for that assignment.
I did work on it.
Okay.
I had all I'm going to be honest with you. I tried to get in and it just didn't.
Okay, so we'll just talk about what we do about 7.1. And then hopefully it'll be rebuilt, and I can, once we hit 7.2 tomorrow, I'll know more on the status.
I will be gone tomorrow.
Okay.
I'll be gone tomorrow.
Oh, for WTC,
Not jazz band? No.
choir and jazz?
Are we
Or
going to have class tomorrow?
Jazz band.
All right, so let me start with how we, just to refresh you, rationalizing the denominator when it was a square root. Okay, so let's say I had 3 over the square root of 3. Okay, when we learned this last chapter, we talked about math grammar, I called it, math etiquette. And for whatever reason, well, I know the reason, because if you have fractional, if I wanted to add this, I can't do it when I've got a root on the bottom. I need to have an integer on the bottom. Okay, so we want to rationalize that square root of 4 is 2, but you understand the idea. We want to rationalize the denominator so we have an integer on the bottom and not a root on the bottom. Okay, so when we did this with square roots, we multiplied top and bottom by that root. Right? Is everybody remembering this? So on top we have 3 square roots of 3. And the square root of 3 times itself is just the radicand, the number under the radical. And now I'm done. Okay, so logic might tell us, if I had this problem, that all I would need to do is multiply by the cube root of 3. This is wrong. This is wrong, and I want to show you why. Okay? Because this is this is what you just jumped to, because that's how we did it with square roots. So it should make sense. Well, let's do this as a fractional exponent. Right? The square root of 3 is 3 to the 1/2. This is what we learned in section 1 when we put a root as a fraction, right? It's 3 to the 1/2. So when I multiply that times 3 to the 1/2, what do I do to the exponents? Add them. So I get 3 to the 1, which is what I wanted. Okay, so let's do the same thing down here. This is 3 to the 1/3, right? When I multiply that by 3 to the 1/3, what do I get? This is still a fractional exponent. Okay, so I want you to think, what could I put here so that I get that 3 over 3? 2/3. So what I need to do to rationalize this, 3 squared, the cube root of 3 squared. Because that's 2/3. When I write the cube root of 3 squared as a fraction, that's 3 to the 2/3. So if I make this 2/3, then that actually gives me the exponent of 1 that I need,
1/3 plus 2/3
is 3/3.
equals 1. Okay.
Yep. So in order to rationalize denominators, my advice to you is write whatever you have as a fraction and ask yourself what fraction you need to add to that to get to 1. And that's the root that you're going to use to rationalize it. Okay? So let me give you one.
No, but okay, got it. What is this?
So would it be,
No, okay, that's a fraction.
this was my answer?
Well, I'll do it for you
I need to do the,
once you're finished. Okay. All right. So what I said was I would recommend that you write this as a fraction. So it's really 2 to the 1/5 power.
Right.
And I need to get it to 2 to the 5/5. That's my goal. Because 2 to the 5/5 is 2 to the 1st. So what plus 1/5 is 5/5? 4/5. So I'm going to multiply this by 2 to the 4/5 over 2 to the 4/5. Okay, I know on the bottom then I'm left with 2. On top then it's going to be 2 times the 5th root of 2 to the 5th, or 2 to the 4th, which is what?
2 1/4.
2 to the 4th is?
8.
No?
16.
16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's my final answer. Would be 2 times the 5th root of 16, which is 2 to the 4th, all over 2. Does that make sense?
yeah.
So most of you figured out what you needed to multiply. You just needed to take it one step further and actually simplify your answer. You want to try another one?
Yeah.
Okay. I'll just do 2.
You want us to simplify?
Mm-hmm.
It's, oh, this is
Okay, I can't. Yeah, I need glasses. So I'll do it and then you check it.
How do you maintain your base like that? It's like always so perfect every day. Mine looks horrible.
Magic. No.
Rats mess my makeup.
like this.
It's like
Yeah.
half a building.
Yeah, hard work.
No.
No, she just had it.
Are we
Yeah, I think we're done, right?
Well,
Are we ready?
I'm done, but
Did you get this?
I know what I need to be
I
getting,
don't
but I'm
remember
not
too.
getting.
okay? So I'll do it and then you can figure out maybe where that disconnect is. Okay. So I'm going to rewrite this as that.
Okay.
Yeah.
Okay. Now I'm going to ask myself, I want to get to 4/4. So what do I need to do?
1 add 3.
3/4. Okay, and so now I know it's going to be over 2 because I did the bottom right. Now to simplify, this is 3, the 4th root of 2 cubed.
That's 8.
Is that it?
Yep, I switched
Okay,
my numbers
but
around.
now wouldn't you simplify to 4?
I can't.
Oh, okay, I got it right.
Okay, I'm going to throw another one at you and see if you can find a shorter way to do it than the way we've been doing it.
Okay, I like that way.
Well, it still works. That way still works. But if you can recognize something right out of the gate, you'll be able to figure out what I mean. And do it the other way if you'd like, and then I'll show you my way and see if we get the same thing.
Whoa. What did you get?
In fact, I'll do it both ways. Are we ready?
That's what I got. Yeah. Yeah.
Okay, so let's do it the way we've been doing it. Rewrite this as 8 to the 1/4. Okay, so I need to multiply it by 8 to the 3/4. Okay, so now I've got 3 times the 4th root of 8 cubed, which 8 cubed, what's 8 cubed? Okay. Over 8. Now, we always have to try and simplify if we have something like this. Just like if we had the square root of 90, we look for 4th roots that go, or the square roots that go into 9, right? And we have to simplify it that way. Same way is true here. We're looking for 4th roots that go into 512. So think of some 4th roots. 1 to the 4th. 1 to the 4th. 1. 2 to the 4th, 16. 3 to the 4th. That's 3 to the 3rd. 27 times 3.
81.
81. So let's just stop there. We've got the first 3. Do any of these 3 numbers go into 512 evenly? How many times? Okay, so I could rewrite this as the 4th root of 16 times the 4th root of 32. This is still all over 8. You just told me the 4th root of 16 was 2, right? So this becomes 2. And I'm left with 6 times the 4th root of 32. Now, doesn't 16 go into this too? So I could rewrite this as 6 times the 4th root of 16 times the 4th root of 2. Right? Because 16 times 2 is 32. All over 8. So 4th root of 16 is 2. So now I've got 12 times the 4th root of 2 all over 8, which 4 goes into 12 3 times and goes into 8 2 times.
Okay.
So this is how I would simplify your answer. I know. What we did, though, is when we had this 512, just like if we had the square root of 90, I'm looking for square roots, squares that go into 90 evenly. 9 and 10. Okay, I did the same thing. I found 4th roots that go into 512 evenly. 16. So I broke it down into the 4th root of 16 times the fourth root of 32. 16 times 32 is 512. Fourth root of 16 is 2. So then I multiplied 3 times 2 to get 6. Then I recognize 32 also has a 16 that goes in evenly. 16, fourth root of 16 times the fourth root of 2. The fourth root of 16 is 2. 2 times 6 is 12. And then I've got the fourth root of 2. Okay? Now, I want to show you a different way, if you had recognized it, to do this problem. That would save most of your simplification at the end. So it's really up to you whether you can recognize it up front or whether you're okay simplifying something bigger at the end. All right, so what I do with 8, I know 8 is 2 to the third power. So I'm going to rewrite this. How do I write this as a fraction? 2 to the 3/4.
Oh, yeah.
Right? The third is on top. The 4 is in the denominator. Okay? So I've got 3 over 2 to the 3/4. So what do I need to add to 3/4 to get 4/4? 1/4. So I'm going to multiply this like this. On top then, I have 3 times the fourth root of 2 all over 2. And it was because I knew 8 was 2 to the third. That's why it's so important. Just like you had to memorize your multiplication tables in 3rd grade, which is what you should have done, all the way to 10, it's important that you memorize your square roots, your cube roots, your fourth roots, at least to 5, so that you can see, as soon as you see 8, 2 to the third pops in your head. Because if I could write it as a smaller base, it makes the end, when I have to simplify, so much easier. I didn't have to worry about having to simplify the fourth root of 512 and getting it down to this. I got it right away because I rewrote 8 as 2 to the third power. Does that make sense?
Yeah.
Okay, I'm recording this. Go back and watch it if you need to. Okay, because it really will help you if you can simplify first. Okay, so let's do a few problems without rationalizing right away the denominator. Let's do the fourth root of 625 cubed. What it says is reduce the following radical expressions. Reduce the following radical expressions. The fourth root of 625 cubed.
I don't have a calculator.
So what do you want us to do?
I want you to simplify that as much as possible. Simplify it as much as possible. There's no denominator here to rationalize. It's just simplifying the numerator. This is what 7.1 was about, was how to simplify these radicals.
Square root doesn't help you here.
This isn't a square root.
It's a
Fourth root.
fourth root.
So who remembers when I told you how to evaluate roots, rational roots in the calculator?
5.
You can use the
You can use the calculator, and what do you have to do?
carrot.
Caret raised to the what?
4.
Okay? Not the 4, the 1/4,
Yeah.
because that's what the 4 represents. But you have to put it in parentheses. What's 625 raised to the 4th, 1/4 power?
5. Would it just be 5 Thursday?
It's 5 to the 3rd power.
So that means
Yeah, 625. So this is 625 cubed, right? Raised to the 4th power, or the 1/4. So I technically could put in 625 caret parentheses 3/4. That little upside down V. It's called a caret. 125. Now, I'll show you why. If I take the 4th root of 625 and then I cube that answer, well, the 4th root of 625 is 5, right? 5 cubed is 125. Okay? That's why if you knew your cubes and your fourths up to 5, it would have jumped out at you. The 4th root of 625 is 5. Okay? Let's do another one. This will be an interesting one. That's what I want. 10,000. First, write this as a fraction. Write this as a fractional exponent. That's what you come up with. You know enough to be able to do it. You just have to think outside the box a bit.
Quite literally.
It's 10.
Yeah, I'm really surprised that I didn't even TikTok firstly.
Write this as a fraction. 10,000 to what fraction?
Well, that's a 2, and this is a 2. So 10,000 to be
Oh my goodness.
So start from the inside. What is this written as a fraction?
10,000 to the 1 over to the half.
Okay? And then
4.
I've got to raise that to the 1/2 because that's what this is, so it's a 4th.
Oh!
And then take 10,000, put it in your calculator if you need to, raise it to the 1/4 power. Yeah. Or just know your fourths. 10 times 10 times 10 times 10
Well, in this
is 10,000.
if you do square root twice and do it,
It works. But it's I want you to be able to recognize that this is 10 to the 1/4, or that 10,000 to the 1/4. Okay, let's try another one. Now you're going to have to rationalize the denominator.
sorry. Happens.
So let's do this one. I'm trying to decide if it's this whole thing that's squared. I would recommend on problems like this that you simplify where you can first.
This is, break it down, Tristan.
I didn't even see this. I've got 2 new markers already.
I have pretty good ink. That was a good one.
It's not.
Let's see if I can make this.
Are you doing this?
My brain is hurting.
The first section.
I think I got it right. We're going to find out. It looks better than theirs, so.
Yeah, it is. Thank you.
You're welcome.
You guys are so shady. Like, what's wrong with you?
because Tristan hasn't.
Whoa,
been around
that's a
people.
big number. I don't think I got this right.
Let me know when you're ready for me to go through it.
Wait,
Do this without a calculator if you can.
alright.
Do it without a calculator if you can.
Simplify where you can first.
How am I supposed to simplify this?
Just let me know when you're ready.
Oh, who? Catherine?
Yes.
I'm not ready.
Okay.
Okay, now I'm ready.
Everybody else ready?
Yeah, I did.
Okay. So I'm going to forget the square for now. I'm going to do that at the end. Forgetting the square. So what I'm going to do is just reduce this if I can. This is the same as the cube root of 8 over the cube root of 81. Okay, I know at the end I'm going to have to square it, so I'll get to that. Okay, so the cube root of 8 is 2. The cube root of 81, well, what number goes into 81 that's a perfect cube? Perfect cube. Perfect cube.
Guys.
So what number times itself 3 times is 6? That's what a perfect cube is. A number times itself 3 times.
2.
Yeah.
2 times.
What number times itself 3 times is 2? That doesn't work. I'm looking for your perfect cubes. So if you're wondering, write your perfect cubes up. What's 1 cubed? What's 2 cubed?
4.
What's 3 cubed?
7. 3 cubed?
3 times 3 times 3.
Oh, we're not doing the force. Okay.
27.
Does 27 go into 81?
Yes.
How many times?
Twice. 3 times.
3 times. Okay, so the cube root of 81 could be simplified to the cube root of 27 times the cube root of 3. Because 27 times 3 is 81. So I'm breaking it out. So what is the cube root of 27?
9. 3.
3.
Sorry.
Okay, so this is 2 over 3 times the cube root of 3. Okay, remember at the end I still have that square to contend with. But for now, this is what I have.
Right.
So how do I rationalize this? I have 3, the cube root of 3.
Well,
Rewrite it as a fraction.
to the 1 3.
So what do I need to multiply top and bottom by? 2/3. Right, that's what 3 to the 2/3 is the cube root of 9. Because I squared 3 to get 9, right? So now on top, I have 2 times the cube root of 9 over 3 times 3. Right, because the whole point of this, if I multiply this times 3 to the 2/3, is I get 3 to the 1 times 3 that I had on the outside is now 9. Now I have to square.
Everything is
Yep. What's 2 squared?
4.
Okay. How do I do this? Well, it would be the cube root of 9 squared. Right? Because when I square, if I have 9 to the 1/3 and I square that, it's 9 to the 2/3 because I multiply. And there's 9 to the 2/3 written as a root. All over 9 squared, which is 81. This is 81, 9 squared. We already did this once, right? What's the cube root of 81? The cube root of 27 times the cube root of 3. Right? So this is now 3. 3 times 4 is 12. Now, what number goes into both 12 and 81?
4. 3.
3. We know 27 times 3. We know 4 times 3. So this is 4 times the cube root of 3. And now I'm done.
I feel like this chapter is going to take a lot of notebooks.
I'm already out of it. I need to go buy some.
That's a lot. And I
Once
think
again, I'm recording this, so it wouldn't hurt at all to go back through it.
It's not gonna me at all.
I need to buy one.
Can we do it again?
Yes, let's do another one. Let's do,
Yeah, me too.
I'm going to get into variables now, so let's do this.
Our shop was closed.
There's 2 letters.
All right, give this one a go.
No, but it's not put on.
I think I rewrite it first.
Yeah, mine red.
Let's just pretend like we're on.
I mean, there's 2 different categories, English and math.
I think get English in
The
here.
first time that I started algebra, I was like, oh, this is fun, we're going to find the x. Well, no.
Sometimes the X stays, okay? Sometimes you ruin your life, and it tells you you're new.
Okay, work.
Whoa.
Yes, let's work so I can do this for you.
Okay. Okay, sorry.
First, I need right out.
Five.
Of each.
What?
Okay.
Would you find 5 roots of x to the 8th, or would you find it out of the 160?
Or both,
Okay.
without a calculator.
Don't touch your calculator.
Okay, so...
Right, your
5,
fifths.
25,
Write your fifths, okay.
125.
So you know it's not going to be 5, because 5 to the 5th is well over 160.
Right.
So work your way down.
2.
So we can find force.
Okay?
4. 4 times 4 is 16. 16 times 16 is 81.
Yeah, and I'll tell you that the 5th root of 160 is not a single number. You're going to have to simplify it. So think of a root, a 5th root of something that goes into 160 evenly.
Okay, so it's not 2, guys.
It's not 4.
Okay, well 12 and 5
So
go
that's
to 16.
Yeah, but neither one of those are perfect fifths. Do 2 to the 5th.
2 to the 5th.
What is not on the calculator?
No.
2 times 2
2 times 2 is 4.
times 2
Is 8.
times 2
16.
times 2. 32. Does 32 go into 160?
Yes.
Is it?
How many times? Use your calculator on this one.
Okay.
Oh.
Wow.
5.
5.
So that equals
So rewrite it knowing what you know now. And I'll do it for you in a minute after everybody's had a chance to try it.
Where do we put the X?
And then
Okay, this is not correct. Kristen? Okay.
32
32 and 5
Two
go into
times
160.
5
So it's going to be 5
X
to the,
4.
of 32 x to the 8 over 5y 7.
yeah, you now you have to do the
X and 1.
now you have to do because you also have to there has to be a 5 now
Yeah.
too. Like you have to times it by 5. You know what I mean?
Are we ready?
Yeah.
I'm going to rewrite all of these.
That's what I did first.
I'm going to treat each one of these separately.
Oh.
That
So the fifth root of 160 is the fifth root of 32 times the fifth root of 5.
See that?
Yeah, I got that.
Me
Not
too.
there.
Okay? This is 2,
Why?
I did not put in.
because the fifth root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 2. That's why we did that.
Okay.
That's how we simplify them. Okay? Now, let's move over to the fifth root of x to the 8th. Well, I could rewrite x to the 8th as x to the 5th times x cubed, right? If I take the fifth root of this and the fifth root of this, the fifth root of x to the 5th is x.
Right.
And then I multiply it times the fifth root of x cubed. Okay? So now I've got this. X times the fifth root of x cubed. Okay? Now in the denominator, I have, if I do the same thing, I have y times the fifth root of what? Y to the, think about what I did here. How would I do the same here?
So 5 and 2. Okay.
Follow?
Oh.
Did a light bulb come on, hopefully?
Yeah.
Yeah.
Okay, now, my issue is I have a radical in the denominator.
Okay.
Can't have that. So I've got to take this, I could rewrite as y to the 2/5, right?
Yeah.
So what do I need to add to that to get 5/5? 3/5. So I'm going to multiply this times y to the 3/5 over y to the 3/5. Okay? So I know that this root, the fifth root of y squared, becomes y. So now I have y squared in the denominator. So I already had a y. Everybody with me? And then in the numerator, if I rewrite this as y cubed to the fifth root, because that's what that is, now I'm going to say everything that's outside of a root is 2x. There's a 2 and there's the x. Then I'm just going to write the fifth root, and I'm going to write everything that's inside. 5 x cubed, y cubed.
Oh.
And I'm done. Just take it one little chunk at a time.
You just blew my mind.
My forehead is actually getting hot from this.
That's interesting.
Did it make sense?
Yeah. Yeah.
I'm going to try another one.
Yes. Please.
Yeah.
Yeah. I think that is better.
Okay, scroll up a little bit. Scroll up.
I just want to pause.
Okay, I just want to see how you broke it down. That's all.
Bring
Okay.
it down.
Okay. Yeah.
I think I got this.
Okay, let's try one more. Hopefully we'll have enough time for me to do it for you. This is a...
Don't you?
Let's get it.
I forced R. 4, 16, 32.
It's not going to be a perfect fourth. You're going to have to think of a perfect fourth that goes into it evenly.
No, that's not 16.
Try your 3s. No?
No, 3
No?
Yeah.
What's 3 to the 4th? It's the 4th root, not the 3rd root.
27 times 27.
Nope, 27 times 3.
81.
Does 81 go into 162 evenly?
Yeah, it does twice.
So now you know how to break it up.
Wait. That's not square root. But 81.
I'm going to start working it just because the bell's going to ring. Okay, I'm just breaking it all up.
That's how I got that.
Okay, 4th root of 81 is 3.
Where I'm at right now.
The 4th root of x to the 5th is x times the 4th root of x. How'd I get that? Well, it's the 4th root of 5/4. 4 goes into 5 one time with a remainder of 1. There's the one time I pull out. It's x to the 4/4 times x to the 1/4. Right? X to the 4/4 is x. X to the 1/4 is the 4th root of x. Everybody good with that? So this becomes x times the 4th root of x. Okay. Now let's simplify these two. I can't reduce this one anymore because it's just y to the 3/4 and 4 doesn't go into 3. Okay? But this one, 4 goes into
10 twice.
10 twice.
So that's 8.
So I can pull z squared out. Right?
So
We have a remainder of 2 inside. The 4th root of z squared. Okay, if I do this, it's z to the 4 over 4 times z to the 4 over 4 times z to the 2 over 4, right? And this is z times z is z squared. Now what is 2 over 4? 1/2. Or no, it's not z squared, it's just 1/2. So now I have 3x times the 4th root of 2x all over the 4th root of y cubed times z squared, the square root of z. The last piece of this then, you'd have to rationalize the 4th root of y cubed, and you'd have to rationalize the square root of z. Okay, at the end.
Thank you.
All right. Yes.